Welcome back. Today we're going to talk about integer exponent notes. In general, it looks like this. We have two basic situations that could happen. Turn on my colors here. And two basic situations that can happen. Okay, so a lot of times when we get these a to the m's or a to the n's, and we get all these variables, we get kind of confused because we're like, what does that actually mean? So I'm going to give you an example so you can see exactly what's going on. A to the m times a to the n actually really looks like this. It would be, for example, like 3 to the fourth times 3 to the second. Okay? Notice the bases are the same. They both have a base of a, so 3 and 3, and exponents are different. Well, when we look at this, if it's 3 to the fourth, times, let me get rid of that, move that down, times 3 to the third, really what we're looking at is how many times is it used. So 3 times 3 times 3 times 3 would be the first one, and then the second one would be 3 times 3 times 3. So total we have 7 of these 3's. Well, the rule says if we have 3 to the fourth, and that 4 keeps getting me, I don't want it to look like a 9. If we have 3 to the fourth and we multiply that times 3 to the third, it really equals 3 to the seventh. So in general, we would say a to the m times a to the n equals, keep the base, add the exponents. Okay, because it works for 3 to the 4 plus 3, 3 to the 7th. This one's a little bit trickier to see, but it's really a to the m over a to the n, and that would look kind of like this. We might say like 2 to the 5th power over 2 to the 3rd power. And again, same base, different exponents. And if I wrote this out, 2 to the 5th over 2 to the 3rd, that would really give me 2 times 2 times 2 times 2 times 2. 5 of them on top, 2 times 2 on the bottom. And what starts to happen is we can start to cancel these out. So these cancel and these cancel. So what I'm left with is 2 to the 3rd on top, 2 to the 0 on bottom, or 2 to the 3rd over 1, which actually just equals 2 to the 3rd. So notice we crossed out until we had 0 of them left on top or bottom, and then we can rewrite. So my general rule, 2 to the 5th over 2 to the 3rd. Oops, I messed that up. You guys should have told me. This would be to the 3rd would actually, 3 of them would go away. So we'd have, I messed it up, 2 squared on top and 2 to the 0 on bottom. So we'd end up with 2 squared. So that almost didn't make any sense. So notice how these things are related. I end up, these all go away on the bottom, and the ones on top, 3 of them go away. So in general, what I'm looking at is, this would be 2 squared. So the general look would be a to the m over a to the n equals a to the m minus n, or 2 to the 5th over 2 to the 3rd equals 2 raised to the 5 minus 3, or 2 squared. So that's my general rule for my exponents. Let's look at an example down here. When we've got these types of things, what we end up with is we have parentheses, exponents, multiplication, division. So PEMDAS. Remember, multiplication, division, same priority. Addition and subtraction, same priority. So let's simplify this. I'm going to simplify this part. My parentheses first. I've got 3 to the 5th times 3 to the negative 8th plus 3 to the 0. Let's recall a couple of properties here. Really, this means plus 1. Okay, so that's going to be by itself. Here I have 3 to the 5th, and this I'm going to make into 1 over 3 to the 8th. So when I multiply those, fraction multiplications, so really this is 3 to the 5th over 1. So fraction multiplication says 3 to the 5th over 3 to the 8th plus 1. Well, now we're going to use this rule here, the division rule. So if I have 3 to the 5 minus 8, so 3 to the top minus bottom, plus 1, so I'd have 3 to the negative third, plus 1, so I'd have 1 over 3 to the third plus 1. And leave it like that. Okay, so simplifying these exponents is really just a matter of checking out what you've got and looking to simplify them using those rules. All right, thanks for watching, guys. We'll see you next time.